User-Centered Design Services Incorporated is a consulting company focused on operational excellence. We implement best practice solutions for reducing the frequency and severity of abnormal situations. Our best practices impact all aspects of plant operation and result in improved plant performance, a reduction in incidents, and improved safety and profitability. We help you improve operator effectiveness by applying human factors and best practices in the control room. Our company president, Ian Nemo, originally founded and directed the Abnormal Situation Management Consortium. He has over 40 years of experience in process control. He's published over 100 papers on control room best practices. His contributions include many standards like the ISA SP18 Alarm Management Lifecycle and the EMUA 191 Alarm Management Guideline. Ian has been involved in hundreds of control room projects and has been recognized as the leader in control room design. Ian is also famous for his book, The High Performance HMI Handbook. The Abnormal Situation Management Consortium was originally focused on alarm flooding, a problem many operators were struggling with. However, we quickly realized the alarm system was only part of a much larger issue, that being unexpected process upsets. Respected professionals from Amoco, Mobil, Chevron, Exxon, Shell, BP, Nova Chemicals, and Texaco joined the research team. Ian brought in an additional $16 million from the National Institute of Standards and Technology to help develop and test solutions to improve the operator's ability to manage abnormal situations. The ASM was completely focused on the operator and the control room environment. Ian has been involved in hundreds of control room studies. He has spent a lot of time with operators and understands their needs. 12 years ago, he started his own company and began writing papers and providing workshops on best practices. Ian has completely updated the ASM practices to incorporate human factor studies from the UK Health and Safety Executive, the DOT, PHMSA, and several cases developed by NASA. In most control rooms, human factors have not been considered in the layout, the console design, or the graphical interface. Research indicates that nearly 80% of production downtime is preventable, and half of this is due to undetected events or poor situation awareness. The cost of this failure in the petrochemical industry alone is estimated at $20 billion per year. Operators have the potential to significantly impact the quality and economic performance metrics of the business, but we have to provide them with the right environment, tools, interfaces, and training. No matter the state of the process, the operator should be aware of everything that is under his control. When the process is stable, the operator should be looking for opportunities to improve production and quality. Many operators are simply reactive. The HMI was not designed for early detection of a problem, so most operators have no choice but to wait for an alarm to activate before they can start to troubleshoot the problem. The biggest challenge for the control room operator is working in a special environment where vigilance is absolutely essential. The environment should be designed based on the operating objectives. They should know and understand the process, and the graphics should be designed based on the operator's tasks, not the PNIDs. They need to be able to easily see the big picture. This is what we mean by the big picture. This is a control room we designed for the Borregaard biorefinery in Norway. They had to make a drastic change to reduce production costs. This caused Borregaard to reorganize all of operations. They went from a multiple control room organization with 12 console operators to a single centralized control room. The large video wall you see here was designed to present critical information to the operators. The data is presented in a way so that the operators can easily look up, do a quick scan, and identify potential upsets well before the alarms activate. The video wall replicates the old analog panel wall of the 1960s. The first thing we did was identify what the operator needed for early detection of potential upsets. Operator involvement was absolutely critical. We developed an HMI philosophy, a style guide, and object library incorporating human factors. The Level 1 graphics provide the large overview displays so operators can see abnormalities as they happen. Level 2 displays contain frequently used operating situations, startup, shutdown, and stable production. Level 3 displays include traditional PNID graphics showing every detail of the process and related instrumentation. Level 4 displays utilize pop-ups that provide the details of devices and group starts. Borregaard originally had 8 control rooms spread out over a few miles. Today, more than 20,000 I/O are managed from a single control center by 6 operators. We performed several studies and provided best practices covering operator workload, task management, HMI design, alarm management, and staffing change assessments. Our head consultants, Ian Nemo and Dave Lee, were instrumental in setting the vision, training, philosophies, and methodologies to create an ergonomically designed control room that pulls abnormal conditions to the foreground. We addressed fatigue, communication, and gave the operators back the big picture. Here you can see the results of a study looking at the time it took the operators to perform tasks during abnormal situations using their original graphics versus high-performance graphics. We identified substantial improvements. The operators detected the abnormal situation before the alarm activated 48% of the time with the new HMI versus only 10% of the time with the traditional graphics. They managed to return the process to normal 96% of the time with the new HMI versus only 70% of the time. And they were able to solve the problems much quicker. On average, it only took them 10 minutes to solve the problem with the new HMI versus 18 minutes with the old traditional graphics. The results show a 5 times increase in detection before alarms, a 37% improvement in the success rate, and a 41% reduction in time to solve the problem. Our most popular services include control room design, layout concepts, lighting studies, console design, high performance HMI, alarm management, operator workload studies, new staffing assessments, and operator training development. We have several best practice documents that we offer, like the HMI philosophy document, style guide and object library, the alarm philosophy, shift handover procedures, and our fatigue management plan. We provide gap assessments on the control room, alarm system, and the HMI. Most of our customers start out with a 2-day workshop covering human factors and situation awareness. For more information, please visit our website at www.mycontrolroom.com.